Hi, in this video we're going to have a little introduction to measuring correlation. The product moment correlation coefficient, denoted by R, describes the linear correlation between two variables. So it measures whether we can draw a line or a line of best fit to represent a trend or relationship between the two variables. I'd like to stress that it only measures linear correlation, not exponential, not any other, only linear. It quantitatively measures the strength of association and the type of correlation, and it takes a value between 1 and -1. So it gives you a number between 1 and -1. A value of +1 would tell us that the two variables have perfect positive linear correlation. Again, that word linear, don't just say perfect correlation, we need to say what type of correlation. A value of -1 shows perfect negative linear correlation, and a value of 0 shows absolutely no linear correlation. Now, the closer R is to 1, or to -1, the stronger the correlation. The closer it is to 0, the weaker the correlation. In reality, R is hardly ever going to be 1, -1, or 0. You're normally going to get values in between. So let's look at a few graphs and scatter graphs and a few examples. So here's an example of perfect positive linear correlation. As you can see, a line of best fit, if we could draw it, would pass through every single point. So that is an example of perfect positive correlation. Here's an example of perfect negative linear correlation. As the x values increase, the y values decrease, and a line of best fit goes right through all the points. Once again, in reality, you're rarely going to see perfect correlation. This is more the type of thing you're going to see. Here the points are more scattered about, but there does seem to be a general trend. As the x values get bigger, the y values do seem to be getting bigger as well, but they're more scattered. R turns out to be not 0.738 in this case. In this one, you can see again they're scattered, but as the x values increase, the y values seem to be generally decreasing. So it looks like we possibly could draw a line of best fit with a negative gradient. And R here turns out to be minus 0.5. So that's moderate negative correlation. It is a small sample size. There's only 10 pairs of values here. This next one has slightly stronger correlation than the previous. So we can see a negative slope between these points, a little bit of scatter at the end, but here they're closer to a line. So this is stronger than the previous one. The previous was about minus 0.5, this one minus 0.6. This one's a little bit stronger because it's closer to -1. Here's an example of hardly any correlation at all. So we have 5 points on the x-axis, some above, one below. You'd be struggling to draw a line of best fit here. You wouldn't know whether to draw it with a positive gradient or negative gradient. You'd really struggle. So the fact this turns out to be negative shouldn't lead us to say, oh, this is negative correlation, because it's so weak. This is very, very close to 0. So here, I wouldn't say negative correlation, I'd say hardly any correlation at all. Here's one version of the formula for R, and this is how it's calculated. Now, good news for A-level maths as of the current specification is we don't need to use that. The Casio ClassWiz calculator can do this for you. So what you do need to know is how to find R using your calculator. I'm going to go through that in a separate video.